One last thing that you should be aware of with regards to O levels computer science is how do you convert a truth table into a boolean expression. Okay, so you will be given a truth table like the one over here, and you are required to produce a boolean expression for this truth table. Okay, in case you are wondering what a boolean expression is, that means you have not watched the earlier videos. Please do go back and look, see what a boolean expression looks like. Okay, now the very the this process is quite simple. The first step is to mark all the rows, mark rows with x is equals to 1. Okay, so wherever your output is 1. Okay, so let's first go ahead and let's do that. So in this row we have the output 1, in this row we have the output 1, and in this row we have the output 1, right? For each of the rows where you have an output of 1, you have to create an expression for each row. Okay, and what you have to really remember is that in creating that expression, each signal is combined by AND gate. Okay, if A is equals to 1, then you have to take A. If A is equals to 0, then in that case take A dash or not A. Okay, so let's do that. This is the first row that has x equals to 1. For this row, the expression is going to be, for row 1, the expression is going to be A is 0, B is 0, and C is also 0. So because all of them are 0, we will take A dot, which is for AND, times B dot, which is again for AND, dot C. Okay, and because all of them are 0, we will put a dash on top of all of them. Okay, the next row, which has x equals to 1, is this one, right? Again, we will not take all these rows because in those rows the x is equals to 0, so we are only supposed to be taking those rows where x is equals to 1. Okay, so for row 2, we will take A is 1, so I will take A dot, B is 0 and C is 0, so we will take B dash and C dash. Right, then for row 3, again let me first get rid of the rest of the markings from other rows. This is gone, this is gone, and this is gone. Alright, for the last row, row 3, this is the row 3 where our output x is equals to 1. So over here A is 1 and C is 1, but B is 0, right? So that means we will take A dot B dash, because B is 0, dot C, okay, because C is 1. Alright, so that was our second step. Create expression for each row. Each signal is combined by AND gate, which is the dot over here. If A is equals to 1, then take A. If A is equals to 0, then take A dash. So we have followed those guidelines to create our expression for each row. Okay, the third and the last step is combine each row using OR gate. Okay, so what we are going to do is basically just take each row. So we will take row 1 and row 2 and row 3 and combine all of them using the OR gate. So OR gate is represented by plus, right? So, and again we will replace the r1, r2 and r3 with their respective expressions. So a naught dot b naught dot c naught. So what have we done? We've taken the row 1 and replaced it with its expression, right? Plus for row 2 it is a dot b naught dot c naught, okay, plus a dot b naught dot c, right? And all of this is equal to x. So we have over here created an expression for the circuit itself, okay? So you can actually go ahead and use this entire expression to represent the circuit. Now one thing you should say at this point is that this expression looks rather complicated, right? And yes, you are right in saying that, because there's actually a way to simplify this process so that you get an expression that is small enough, and hence you are also able to draw a simpler circuit. The circuit and the expression both for this kind of boolean expression is going to be very difficult, right? So yes, simplification is possible, but that's not really part of the syllabus right now, okay? So I would advise that you try this example by yourself by going to the start of the video and doing it yourselves.